following is a tutorial on naming compounds. Okay, so the first step when we are naming a compound is to look at the elements that are present. So in this first compound, I have phosphorus and oxygen. So what I'm going to do is I'm going to take a look at my periodic table and locate those. So phosphorus and oxygen are both nonmetals. So that means that they are going to make a covalent bond. And when we are naming covalent compounds, we are going to use prefixes. Okay, so we look at the first nonmetal, and it is phosphorus. Okay, there is a subscript of 2, so that means that there are 2 of them. So the first part of the name will be diphosphorus. We just add a prefix in front of the name of the first nonmetal. The second one is oxygen, and there are 5 oxygen. So the next part of the name will be pent for 5 oxide. Okay. This is what we consider a binary compound. There are only 2 different elements present. In all binary compounds, we end the second part of the name in IDE. Okay, so moving on to the next compound, we have silicon and oxygen. Okay, so silicon is considered a semi-metal or metalloid, and it actually does make a covalent bond with oxygen. Okay, so you can think about covalent being both nonmetal plus nonmetal, or sometimes a semi-metal and a nonmetal. Okay, so silicon is our first element. There's only one silicon, so I'm just going to name it silicon for the first part of the name. And then the second part of the name, I've got 2 oxygen, so I'm going to use the prefix dioxide. Okay, again, a binary compound, there's only 2 different elements present, so we're going to end the second part of the name in IDE. Okay. Next compound, we have magnesium combined with OH, and you can see that there's parentheses around here, so that means we have 2 OHs. Okay, so here we go. We've got magnesium right here, oxygen, and hydrogen. So we have a metal present, which means we have an ionic compound. Okay, so when we're dealing with ionic compounds, we have basically 2 different naming systems. So in this case, we're going to look and we see that we have more than 2 elements. This is not a binary compound. There are 3 elements present. So if we have more than 2 elements, we're going to have to look at our polyatomic ions. So the first part of this compound is magnesium. Magnesium is the metal. So the remaining part will be our polyatomic ion. Okay, so we look on our sheet. On this side I've got them in alphabetical order by the elements. So we're looking for OH. So we find that right down here, and that is called hydroxide. So when naming an ionic compound that contains a polyatomic ion, you're just going to name the metal first, so magnesium, and then you name the polyatomic ion. Magnesium hydroxide. We do not need to indicate that there are 2 hydroxide in the name. That would be assumed because magnesium always makes a 2+ ion, and then hydroxide makes a 1-. Okay, I will be posting an additional video that explains how to write formulas, so that will go more into that. Okay, next one. We have zinc and phosphorus. Okay, zinc and phosphorus. So we have a metal combined with a nonmetal, so we know that this is an ionic compound. But in this situation, we notice that zinc is a transition metal. So the elements here in this blue box are considered transition metals. They make variable ions, so you need to indicate the charge when you write the name. So zinc 3p2. So the first thing I'm going to do is I'm going to try to figure out what the charge is on zinc. And I can do that because I know how many of each are present. We know that the charges have to add up to 0. And we do know what the charge is on phosphorus. So if you look here, phosphorus makes a 3- ion. So there are 2 phosphorus atoms because of the subscript of 2, and the charge is -3. So 2 times -3 is -6. Okay, that means I have 2 phosphorus ions, so overall that's a -6 charge. I needed 3 zinc atoms to cancel out the charge, and I know that they have to add up to +6. Okay? The positive charges and the negative charges need to add up to 0. By definition, ionic compounds do not have an overall charge. So we are trying to figure out what the charge is on zinc, so I'm going to call that X. So the question is 3 times what is +6? And the answer is 2. So I have zinc 2. Okay, so the Roman numeral indicates the charge on the transition metal. And then this is a binary compound, so I'm going to name the non-metal with an IDE ending. So it becomes phosphide. Okay, next compound, I have potassium and sulfur. Potassium's right here. It's not a transition metal, and it is being combined with sulfur, so this is just a regular ionic binary compound. So I'm going to name the metal first, which is potassium. And then I'm going to name the non-metal second with an IDE ending. So potassium sulfide. Okay, we don't need to indicate the charge on potassium because potassium always makes a +1 ion based on its location on the periodic table. The reason why we indicate the charges for the transition metals is because they change. Okay, so next compound I've got copper, phosphorus, and oxygen. So automatically I know that I have a polyatomic ion present because there's more than 2 elements. Okay. So we've got copper right here. So again, copper is a transition metal, so we're going to be needing to indicate the charge on that. Phosphorus and oxygen are non-metals, so we know this is an ionic compound. So first, let's figure out the charge on copper. So we're going to look for PO4 on our list, and we'll find that right here. Okay, so phosphate, and we know that it has a 3- charge. So we have 2 phosphate molecules. And the charge is -3. So the negative charges add up to -6. So again, just like in the last example, that means I've got PO4, 3-, PO4, 3-. 2 of those, so that adds up to -6. Okay, we have 3 copper atoms present. And we don't know what the charge is, but we know that the charge has to add up to +6. Okay, these need to be equal and opposite. So 3 times what is 6? Again, we have a +2 ion. So this will be copper 2 phosphate. Okay, so whenever we have a polyatomic ion, you just name the polyatomic ion. Okay. Now in this example, I have all nonmetals present. This is one of the stranger polyatomic ions because it makes a positive ion. So if you see NH4, you automatically should know that that is ammonium, which is a positive polyatomic ion. So we're going to name this ammonium chloride. I'm going to add one more example on here. Okay, so we have iron, sulfur, and oxygen. Iron is a metal, so we know we have an ionic compound, and it's also a transition metal. So that means that we need to indicate the charge on iron. Okay. So we're going to look up SO4, okay, because we know the first part is the metal, the rest of it's going to be the polyatomic ion. So I look up SO4 on my chart. SO4 has a 2- charge, and it's called sulfate. So I have 1 sulfate atom, not 4. So remember, we got the metal first, so the rest of this is the polyatomic ion. SO4 is the polyatomic ion. And we have 1 SO4. If there was more than 1, we would use parentheses like these previous examples. So 1 times -2, because that's the charge on sulfate. So we know the overall charge on that is -2. And we have 1 iron atom. We don't know what the charge is, but it has to add up to +2. They have to be equal and opposite. So again, 1 iron atom times the charge, and we know that it has to be equal and opposite to the charge on the negative ion. So 1 times what is 2? The answer is 2. So this will be iron 2 sulfate. Okay, we don't add any endings when we have a polyatomic ion. All right, in the next one, I've got copper and oxygen. So here's copper. It's a transition metal, so we're going to need to indicate the charge on that. And it's combined with oxygen, so we have an ionic compound. Let's look up the charge on oxygen. It's -2. I have 1 copper atom. I'm going to change this. I have 1 copper atom, and the charge is -2. So overall, negative charges add up to 2. And in this example, I have 2 copper atoms. We don't know what the charge is, but we know it has to add up to +2. So 2 times what is 2? And the answer is 1. Wanted to include an example where we didn't have a +2 charge. Copper 1 oxide. Okay, binary compound, so we name the metal, and the nonmetal with an IDE ending.